Hello, welcome to the video. In this lesson, we're going to be looking at section 3.1, where we're going to concentrate on functions. The central question that was given to us here, it says, what is a function? So up to this point, we've been able to, maybe not in this class, but in previous classes, you've been able to take a look at a coordinate plane, so like an XY coordinate plane. So the vertical line here is our y-axis, and the horizontal line here is our x-axis. Everything that you can place on a coordinate plane is called a relation. All right, there's different ways to represent a relation on a graph. We'll get into uh, some of those depictions in a little bit, but mainly we are looking at x and y coordinates. All right, x and y coordinates mean that the x values go either to the right or to the left, depending on if the x value is positive or negative. These are my positive values for x. These are my negative values for x. And my y values either go up or down. So whether it's positive or if it's negative. So this would be positive values for y. This would be negative values for y. Definition of a function is they're saying that for every input, you have exactly one output. Now, there are other ways that you can determine what an x and y value actually mean. Another way of calling your x values on your coordinate plane is call it an input. Another thing you could also call x is more often not, it's called the independent variable. When you look at y, those are your outputs, and those are more commonly known as the dependent variable. So when they say that you have a function, it's a relation where for each input there's exactly one output. What really that means is for a relation to be a function, you cannot, I repeat, you cannot have any x value that repeats. That's essentially what that means. For every input, there's exactly one output. So that means there's no repeats in the x value, or no repeats in the input, or there's no repeats in the independent variable. So we're going to look at a few ways to represent a relation, and then from those representations, we're going to determine if those relations are functions. If you look at examples A and examples B, one of the ways to represent a relation is through an ordered pair. So these are all ordered pairs. Negative 2 comma 2, negative 1 2 0 2 1 0 2 0. Those are all xy coordinates that are represented as an ordered pair. If we look at example C, this is considered writing it as a table. Writing it as a table is still the same, has the same idea as the ordered pair. You're just writing it as a table. You can write it as a table like this, or you could write it as a table like this, where your x and y coordinates are there. It kind of depends on either A, how the example shows it, or how you choose to illustrate it. Another way, like example D, is called, this is called a mapping diagram, where you have your inputs on one side and your outputs, and then you have an arrow pointing towards them. And then the final one that's not listed here is just a graph itself. So they'll have points at certain ordered pairs, and then you have to kind of decode the graph to uh, determine if those relations are functions. So it asks us to determine whether each relation is a function they want us to explain. So example A, we have these ordered pairs. What we have to check is, do we have any x repeats? So I got -2. Do I have a repeat? No, 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 no. We're good with -2. Do I have a repeat with -1? No, 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 we're good. Do I have a repeat with 0? No, no. Do I have a repeat with 1? The answer is no. So there's no x, so no x repeats. That is an indicator that yes, this is a function. Looking at example B, I start off with 4 as an x coordinate. Do I have a repeat? No, no, yes. Right here and here I have 2 ordered pairs that have a value of 4. Since 4 repeats, it's not a function. It's still a relation, it's just not a function. Looking at C, do I have any repeats for x or in the input? Yes, I do. I have repeats of 0, so 0 repeats. The number 0 repeats, I'll say. So not a function. Gotta learn how to spell function. There you go. And now over here with the mapping diagram, so essentially what I'll do is I'll rewrite this as an ordered pair to kind of illustrate this. So this is -1 comma 4. This is 3 comma 15, and this is 11 comma 15. So that is another way of kind of depicting what the mapping diagram is showing. There are no x repeats, no x repeats. Yes, it's a function. Another way of being able to determine if a graph is a function is, does it pass what is called the vertical line test? So you could use like a ruler or a pencil. In this case, I'm just going to make a vertical line myself. And at any point, if you notice, oh, it hits that vertical line at more than one spot, you can then say that that particular relation is not a function. So this one here, it keeps hitting two spot, like right here, it hits at one spot, but you just have to show one at one particular situation where it would hit at more than one spot, then it's not a function. If you look at this, just intersects at 1, 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 intersects at 1. So these are situations where this passes the vertical line test, which would then make it a function. So here, it's asking you to determine if the graph represents a function. They ask you to explain. You know, you could just see, all right, let's get our vertical line test and see if in fact it does pass. So like if you look at example A, right here, it intersects two spots So that means it doesn't pass the vertical line test. It intersects here and it intersects here. So the explanation you could say is doesn't pass the vertical line test. So not a function. Also, you could say like, well, this is 2 comma 2. Here, this is 2 comma 5. Oh, look, I got an X repeat. So that is another indicator that it's not a function. I go over here. It looks like it's continuous on and it only intersects one time. So it does pass the vertical line test. So B would be a function. Here again, they're asking you to determine it. 5, this would pass the vertical line test. So yes, this is a function here. 6, yes, this would be a function. It does pass the vertical line test. 7 would be no, and 8 would be yes. Those, everything with yes would pass the vertical line test. No, it would not pass the vertical line test. A couple of terms that we're going to be asked to define or represent, not only in this lesson here, but in future lessons as we move forward, is being able to establish what the domain and range is of a function. So once you've established that a relation is a function, what is the domain and what is the range? Domain is a part of the function that talks about all of the possible input values, or what are the possible x values that are part of that function. The range is talking about all of the outputs or all of the y values. So it's an indicator, or it's a way of showing how to determine what every value for x and every value for y without making a list. Sometimes you have to make a list depending on the situation, though. So for example A, so if you look at example A, you just have points on a graph. I have points here, 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 and here. Since there's no line that connects them at this point, we have to name those points individually with respect to its domain range. So the domain is going to be the x values of those points. So for this one, it's -1, -2, -3. The next point right here is -1. The next point here is 1. And the last point here is 3. So those are, in this particular instance, the x values for this particular situation. And because they are points, we have to make that list. For the range, now we're just going to make a list of our y values. So the range would be, so it looks like it's going to be -2, negative, it looks like 0. And then we got 2, and then we got 4. So those are the lists of our y values for those particular points. If you look at B, if you notice, yeah, there's points. There's a point here. Make it better. There's a point. There's a point here, and there's a point here. But between those 2 points, there's like line segments that connect them. So we have to illustrate all of the x values and all of the y values for that particular situation. So in order to do that, what we have to do is look at, okay, our x values start here and kind of end here. So these are all our x values. So this, everything between here and here is going to make up our domain. Okay, so if I were to choose any x value in the domain, whether it's here, whether it's here, whether it's here, I want to establish all of them because that's what the definition of domain is. So it starts at what, -1, -2. So -2 is over here and it ends at 3. So that means we could choose any value for x between -2 and 3, and we would get a value for our respected domain in this particular situation. So essentially what you're going to do is you're going to write this as like an and statement because x for our domain can fall between -2 and 3. Because it's an and statement, we are going to illustrate it like so. Because it can be -2 because it's part of the function. It can be 3 because it's part of the function, but it can fall anywhere between those two numbers as well. Looking at our range is our set of y values. So our range is going to fall between here and here, where I have it illustrated here in green. It looks like it's -1 on the bottom, looks like it's +2 on the top. So if I am going to, again, any value of y can be part of our range. So y is going to fall between -1 and 2. So I'm going to now write this as an and statement. Okay. Looking at example 9, again, this is another situation where we have points. So we got points here, 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 and here. So these are all essentially integers, so we just can make the list. So I got my domain, starts off with -2, it goes down to, looks like -1, looks like 0, looks like, excuse me, this would be 1, and finally it finishes up with 2. And you want to write it in order from least to greatest. All right, so now looking at the range, if you notice here, you have some repeat values with your values of y, because like this was 0, 0. This here was 1, 2. This was -1, 2. You can have repeats in y, you just can't have repeats in x for it to be a function. This is 2, 4. This is -2, 4. You only have to write a singular number once. So for the range, my values are going to be 0, 2, and 4. I don't have to write it twice. I only have to write it once. So that is my domain and range for that particular situation. When I look at 10, again, my domain is going to fit between here and here. So because I have the line that continually writes, so there's a particular stopping point and a particular ending point, I can now say, all right, well, x is going to fall between 1 and 5. So it's going to be, again, my and statement where it's between 1 and 5. My range is going to fall between here and here. Looks like uh, the smallest number is 0, and my largest number for y would be 4. So it's going to fall between 0 and 4. So here it says that you have a function. Y equals negative 3x plus 12 represents the amount of Y in fluid ounces of juice remaining in a bottle after you take X gulps. They want you to identify the independent and dependent variables. So the independent variable, like I said, is normally the value of X. So X is your independent variable, and it's an indicator of how many gulps that you've taken. And depending on how many gulps, Y is your dependent variable. How many fluid ounces are left in your juice bottle? So they're having here, it says that you have a domain of 0, 1, 2, 3, and 4. What is your range? So you could make a table here. So I got X, I got Y. X is domain, so it's 0, 1, 2, 3, and 4. To find your ranges, what you're going to do is you're going to use this formula and you're going ahead and solve. This is now going to be y equals negative 3. And now you're going to replace x with the first domain, which is 0. And then this is now going to be added by 12. So now negative 3 times 0 plus 12 is 12. I go over here, next one, negative 3 times it by 1 plus 12. That's going to be 9. Y is equal to negative 3 times 2 plus 12. That is 6. Y is equal to negative 3 times 3 plus 12. I get 3. And then finally, y is equal to negative 3 times 4 plus 12. Ends up being 0. And my ranges, if you want to make a list of it, would be 0, 3, 6, 9, 12. And that is looking at functions. Hope this helps. Until next time.